Welcome to this video here where we're going to just take a look a little bit on prime factoring and specifically on how we can use it to find a perfect square or perfect cube. We're going to look at perfect cube in this case here, and then just to describe the process that we go through with that. So let's take a look at the number 1728. Now, if you take the cube root of that, you're going to get a whole number because it is in fact a perfect cube. Now I want to show you how you can do that without taking the cube root of it and using a method called prime factorization. Now we're going to start by factoring 1728. Okay, so here's 1728. Now one of the ways that I show my classes how to prime factor is just to start dividing numbers out. And you can use a calculator for that. I'm going to pull my calculator out. Okay, so here's my calculator. Might be a little backwards in there. And so on here, I'm going to type in 1728. All right. Now, let's start by dividing out prime numbers. Okay. The first one I'm going to divide out is 2. Okay. And when I do that on my calculator, there we go, I get an answer of 864. So that means that 2 is one of our prime factors. Okay. All right. So we got that. Now, it's still an even number. So I'm going to divide by 2 again. And we're still getting a nice number, so that means that we can again do 2 again. And let's keep trying. Well, we can do 2 another time, and another time, and another time, and another time. And when we do all of this, we're going to get to the point of 27. So when we divide by 2 each of those times, we're going to come down to 27. Now 27 is not a prime number. Or sorry, is not a prime number, but it's also not an even number. So we can't divide it by 2, but we can maybe try 3. And we're going to try 3, and sure enough, it works. We'll get down to 9. Divide 9 by 3, and we get down to 3. And we can divide 3 by 3 and come to 1. So now we have prime factored 1728. You'll notice that there are 6 2's and 3 3's in there. And when we multiply them all together, we would get 1728. So if we want to try to figure out if something is a perfect square, we want to take these numbers and divide them into 2 even groups. In fact, it's not going to work here. We could divide the 2's into even groups, but we can't divide the 3's into even groups. So it tells us that 1728 is not a perfect square. But is it a perfect cube? Can we divide each of these into 3 separate groups, okay, evenly? Well, let's try. So here we go. So we're going to move the 2's into those 3 groups, and we can do another 2 in each group. Good, that's so far good. And then the 3's can each go into a group as well. And you'll notice that we have 3 groups which are identical, and we should maybe keep the multiplication in there, because when we multiply each of these groups together, we're going to get the answer of 12. Now, if we get these even groups here, it tells us that this number is in fact a perfect cube, and the cube root of 1728 is 12. If it doesn't work, we're going to have a non-perfect cube, and that's okay, and it's totally fine. But this just gives us an idea as to where we can see that similarity working using prime factorization. Hope this helped you. If you have any questions, gladly leave a comment and I'll try to respond to you and try to help you out a little bit, or you can talk to a math teacher as well. All the best.